10 fireballs in 1 month. The previous record was 6. The average has been 2. But March 2026 just broke every number in the modern tracking era, and the month is not even over. NASA logged it. Scientists ran the statistics and landed on 4.5 sigma, which is science's way of saying this should not be happening. 79% of the largest events produced sonic booms. Fragments landed in Germany, Ohio, and Texas. Same rare mineral, same asteroid fingerprint in 3 countries over a period of 9 days. Claims that the military is intercepting alien probes from interstellar object 3I Atlas are going massively viral. The official explanation is seasonal variation. The data disagrees loudly. But here is the thing about debris streams. When you see the small fragments first, something bigger may be following behind them. Stay until the end, because you need to hear what that really means. If you genuinely enjoy what we cover here on Project Nightwatch, make sure to hit like and subscribe, because this story is not finished. The fragment analysis is still coming in, the fireball data is still being updated in real time, and the next few weeks of April observations are going to be telling. Drop a comment below with where you're watching from, what time it is there, an honest answer. Does 10 fireballs in 1 month feel like coincidence to you, or the opening act of something much larger? Part 1. The 4.5 sigma problem. 10. That is the number of significant fireball events NASA has logged for March 2026, and the month is not even over yet. 10 major atmospheric entries, tracked by satellites, confirmed by multiple witnesses, some of them rattling windows and shaking foundations across entire states. 10 events in a single month, where the historical average, the long-run, multi-decade, boring and reliable average, sits at 2. Not 7, not 5, 2. And the previous record, the single highest month ever captured in the modern tracking era, was 6. We just blew past that like it wasn't even there. Now, before you reach for a comfortable explanation, before your brain starts whispering things like, "It's just better cameras," or "It's a seasonal thing," I want you to sit with that number for a second. 10 against an average of 2. That is not a blip. That is not noise. A geologist and geophysicist named Stephen Burns ran the statistics on this, and what he found was a 4.5 sigma deviation from the expected mean. 4.5 sigma. If you're not familiar with sigma as a concept, here's the version that matters. A 1 sigma event happens all the time. It's just a normal fluctuation. A 2 sigma event is a bit unusual. A 3 sigma event starts turning heads in scientific circles. A 5 sigma event is the threshold particle physicists use before they'll even consider announcing the discovery of a new fundamental particle. 4.5 sigma sits right below that bar. You're not dealing with bad luck or a quirky month. You're dealing with something that, under a stable random system, should almost never happen. And here's where it gets interesting, because Stephen Burns did not stop at the headline number. He kept tightening the filter. He kept asking harder questions of the data, and every time the threshold got stricter, the signal got stronger, not weaker. That detail is going to matter enormously before this is over. So what exactly qualifies as a significant fireball? The events we're talking about are not the average shooting stars you see on a clear night, the little streaks of light that last a fraction of a second and leave nothing behind. A significant fireball clears a specific energy threshold. It gets detected by government satellites, in some cases by systems that were built to monitor nuclear detonations, which should give you a sense of the energy scales involved. It generates multiple independent witness reports across wide geographic areas. In several of the March 2026 cases, it produced sonic booms loud enough that people called emergency services, convinced something had exploded nearby. These are not shy events. These are the kinds of entries that, historically, you would expect to see a handful of times per year, and we are getting them at a rate that implies something has fundamentally shifted. There is also a reporting lag baked into this that makes the number potentially conservative. NASA's Fireball event page is not a live feed. Events are verified, processed, and uploaded after the fact, often days later. Which means that the 10 events currently on the books for March 2026 may not be the final count. The real number could be higher. The official position, when you go looking for one, is something along the lines of sporadic meteor activity is naturally variable, and the vernal equinox period produces a modest increase in observable events due to Earth's orbital geometry. That is a real phenomenon, and we will get to exactly why it cannot explain what we're seeing. But here is the one-sentence preview. The equinox effect is documented to produce increases in the range of 10 to 30%. What we are observing in March 2026 is an increase of several 100%. Invoking a 10 to 30% mechanism to explain a several 100% anomaly is not a scientific explanation. It is a placeholder, and this is where the tension lives, the tension that is going to drive everything that follows. On one side, you have institutions whose job it is to characterize Earth's space environment, and whose current public position is essentially, nothing unusual here, move along. On the other side, you have independent researchers staring at datasets that are breaking every pattern simultaneously. The question that should be forming in the back of your mind right now is a simple one. What changed? Was it something about the space environment itself, the population of objects out there, the density of material Earth is moving through? Or is it something about our ability to detect what was always there? Because those two answers have very different implications, and only one of them should be keeping planetary scientists up at night. Here is what I can tell you right now. Fragments have been physically recovered from 3 separate impact sites. Sonic booms are being reported at a frequency that has no modern precedent. Geographic clustering of these events is producing patterns that independent analysts are describing as statistically improbable under any random model. And the data, when you look at the full shape of it rather than just the headline count, reveals something more structured and more unsettling than a simple spike in numbers. If this were random noise, it would not break every pattern at once. Part 2. The pattern. Inside the pattern. The American Meteor Society has been collecting fireball reports since 2011. That is 15 years of data, standardized enough to make real comparisons, broad enough to establish genuine baselines. When you look at that database and compare every previous March to March 2026, something immediately jumps out, but it is not what you might expect. The bottom of the distribution is basically unchanged. Events in the 10 to 24 witness range, the smaller, dimmer, lower energy fireballs, are coming in at roughly normal rates. If this were purely a detection effect, if the explanation were something like, more people are reporting things now, you would expect to see the entire distribution rise together. More reporters means more reports at every level. That is not what the data shows. What the data shows is that the base of the distribution is stable, and the top of it has gone into territory that has no precedent in the entire 15-year dataset. Events with 50 or more witnesses, events with 100 or more witnesses, events with 200 or more witnesses, every one of those upper-tier categories has surged in a way that the lower tiers have not. And this is not a subtle effect. The average witness count per event for the significant fireballs in March 2026 comes in at approximately 142. The previous record for any single month sat at approximately 49. You're not looking at a 10% jump or even a 50% jump. You're looking at an increase of nearly 3 times the previous record average, concentrated entirely in the high-end events. Now, one event in the dataset deserves a specific mention because it has the power to distort the numbers. The Germany fireball from March 8th, which generated 3,229 individual witness reports. A single event with a witness count so extreme, it barely fits on the same scale as anything that came before it. If you remove that event entirely from the March 2026 calculations, the remaining average is still dramatically elevated above any prior March in the dataset. The Germany event is not holding the anomaly together. Take it out, and the anomaly is still there. Here is why the distribution shift matters more than the raw count. When you see an event with 200 or more independent witnesses reporting it across a wide area, you're not seeing a small rock burning up high in the mesosphere. You're seeing something bright enough, large enough, and deep penetrating enough to be visible across a geographic footprint that spans hundreds of kilometers. More witnesses means more brightness. More brightness means more energy. More energy means a larger object surviving deeper into the atmosphere before it fragments or ablates away entirely. The high-end witness counts are a proxy for physical size and energy, and every one of those proxies is pointing in the same direction. There is a useful analogy here. Think about adjusting the contrast on a photograph. When you increase the contrast, the things that were barely visible in the original become obvious, and the things that were already obvious become unmistakable. What Stefan Burns found when he tightened the thresholds, when he applied stricter and stricter filters to the data, is that the signal got brighter, not dimmer. Every filter he applied that should have stripped out noise if this were a reporting artifact instead revealed more structure. That is the opposite of what you would expect from a database contaminated by increased reporting bias. That is exactly what you would expect from a real physical shift in the population of incoming objects, skewed toward larger sizes. So let me be direct about the implication here, because it is important to get it on the table before we go any further. We are not just seeing more meteors, we are seeing more large meteors. The size distribution of what is entering Earth's atmosphere in early 2026 appears to have shifted upward in a way that the existing data has no parallel for. And when objects are larger and denser, and penetrating deeper before they break apart, they tend to do something very specific and very audible on the way down. Part 3. The Sonic Boom Era. Approximately 79% of the large fireball events tracked in the first quarter of 2026 produced confirmed sonic booms. 79%. Let that settle for a moment, because that number is not normal either. A sonic boom from a meteor entry is not guaranteed. It requires a specific combination of factors. The object needs to be substantial enough in mass, dense enough in composition, and penetrating enough in trajectory to survive deep into the lower atmosphere, below the altitudes where most meteoric material burns up, before it sheds enough mass or velocity to stop producing the kind of atmospheric disturbance that arrives at the surface as a physical shock wave. The boom you hear is not the impact. It is the object's passage through air that it is compressing faster than sound can travel. You're hearing the sky being physically displaced by something moving at hypersonic speed. The fact that this is happening at a rate of roughly one confirmed boom-producing event every 3 days in this period is extraordinary. Compare it to previous years. 2021 saw elevated sound-producing rates from fireball events, and 2023 showed similar patterns. But in both those years, the total event counts were lower. What made those years notable was the percentage. What makes 2026 different, and this is the key distinction, is that both the percentage and the count are elevated simultaneously. In prior anomalous years, you had unusual rates applied to small numbers, producing a manageable total. In 2026, you have unusual rates applied to an already unprecedented count of large events. The product of those two elevated numbers is something with no clean comparison in the modern record. Two events in particular anchor this story in a way that makes the statistics feel very concrete and very physical. On March 17th, a fireball entered the atmosphere over Ohio in broad daylight, which already tells you something about its energy, because a meteor bright enough to be distinctly visible against a sunlit sky is not a small thing. Subsequent analysis put its estimated mass at approximately 7 tons. 7 tons of rock hitting the atmosphere at meteoric velocities releases energy measured in the equivalent of tons of TNT, and the Ohio event released approximately 250 tons worth. 250 tons of TNT equivalent in the middle of the afternoon over a populated state. Sonic boom was confirmed. Multiple sensor arrays picked it up. People across a wide area reported physical vibrations. 4 days later, on March 21st, a fireball event over Texas added another data point. Smaller than Ohio, the energy estimate comes in around 26 tons of TNT equivalent, but still well above the threshold that produces booms, and still generating the kind of atmospheric signature that gets picked up by systems not designed to track meteors. Specifically, the GOES Weather Satellite Network, which carries lightning mappers sensitive to plasma flashes in the upper atmosphere, detected the entry as a brief but distinct optical pulse. You're being tracked by systems built to watch for lightning and nuclear detonations, and they are logging you as an event worth noting. That is the energy tier we are operating in. The deeper implication of all this sonic boom data connects back to the central question we're building toward. If you are seeing a higher percentage of objects that survive deep enough to produce shockwaves, you are seeing a population of incoming material that is skewed toward denser, more coherent, more structurally robust objects. Fragile, loosely bound material, the kind that makes up a lot of common sporadic meteors, tends to ablate quickly in the upper atmosphere. It burns bright and dies high. What produces a sonic boom is something with enough structural integrity to push through that upper atmosphere ablation zone and keep going. The boom is a symptom of composition and mass, and the composition question, it turns out, has a very specific and very strange answer for at least 3 of the March 2026 events. Part 4. The Fragment Coincidence. 3 of the March 2026 events left something behind. Not just craters or scorch marks or witness testimonies, actual recoverable material. Physical fragments sitting on the ground available for examination. Germany on March 8th, Ohio on March 17th, Texas on March 21st. 3 separate events across 3 separate countries on 2 continents, all producing recoverable meteorites within a 13-day window. The physical description of these fragments, reported from the recovery sites, follows a consistent pattern. Dark exterior fusion crust, the charred, glassy coating that forms when a rock passes through the atmosphere at hypersonic speed, and its surface literally melts and resolidifies. Grey-white interior when fractured, with a texture and mineralogy that recovery teams found distinctive enough to attempt a rapid field classification. The preliminary assessment, based on visible characteristics and early analysis, placed all 3 finds in or near a category called HED chondrites, specifically a subclass known as eucrites. Eucrites are not common meteorites. They are not the generic chondritic material that makes up the majority of falls, the carbonaceous or ordinary chondrites that represent the bulk of what hits Earth. Eucrites are a specific igneous rock type with a chemical signature that has been traced, with high confidence, to a single source body in the solar system, 4 Vesta, the second largest object in the asteroid belt. Vesta was heavily impacted billions of years ago, a collision so violent it excavated a basin called Rhea Silvia that is almost as wide as Vesta itself, and that impact scattered a family of fragments, called vestoids, throughout the inner solar system. Most eucrit falls on Earth arrived as individual fragments that have been wandering for millions of years. They are not common. What the American Meteor Society flagged as statistically unusual is this: 2 events with eucrit-like fragment characteristics, separated by 9 days, is outside the expected probability of random coincidence given how rare eucrit falls are in the baseline record. 2 in 9 days at this energy scale is a pattern that demands an explanation beyond "it happens sometimes." But here is where the coincidence stops being comforting and starts being strange. When researchers compared the entry trajectories, the radiants, meaning the calculated direction in space from which each object arrived, for the Germany event and the Ohio event, the angular separation between them came out at approximately 98 degrees. 98 degrees. That is nearly a right angle in the sky. These 2 objects, apparently made of the same rare material, came from directions that are almost perpendicular to each other. The implication of that geometry is significant. A compact debris stream, a tight, coherent cluster of fragments from a single breakup event, would produce objects arriving from a consistent radiant direction. Objects that arrive from near-perpendicular directions cannot both belong to a single compact cluster. They are either coincidental arrivals from different parts of a very broadly distributed debris field, or they represent separate streams that happen to share a compositional origin. Or, and this is the uncomfortable option, the classification is wrong, and the similarity is an artifact of preliminary field assessment rather than confirmed lab analysis. That last caveat is worth keeping in mind. The eucrite classification for these fragments has not, as of this writing, been formally confirmed through laboratory analysis. It is based on field observation and early assessment, and the source of that classification is preliminary rather than peer-reviewed. But if it holds, if the lab work confirms what the field teams reported, then you have a question that does not have a comfortable answer. Same rare material. Perpendicular arrival directions. Either the debris field that produced these objects is spread across a region of space so large that it subtends nearly a right angle, as seen from Earth's orbit, or something more complex is happening with the population of incoming material, and that question, where exactly these things are coming from, is one that the data so far cannot fully answer. Part 5. The Geographic Concentration Problem. Look at the map of where the high-profile March 2026 events are concentrated and something becomes immediately obvious. The United States is getting hit, or at minimum the United States is where the recoverable events, the confirmed sonic boom events, and the most energetic entries are being reported. Germany breaks that pattern early in the sequence, but as the month progresses, the geographic weight shifts heavily toward North America, and specifically toward the continental United States. This raises a question that has to be asked honestly before it can be answered. Is this a real physical clustering, or is it an artifact of where the best detection infrastructure exists? Because the United States does have exceptionally dense fireball reporting networks. The American Meteor Society's reporting system is one of the most active in the world. The GOES satellite coverage over North America is comprehensive. The population density of the eastern and central United States means that when a fireball crosses the sky at 2 in the afternoon, there are millions of potential witnesses below it. All of that is real, and it genuinely could inflate the apparent concentration of events over US territory relative to, say, Central Asia or the South Atlantic. But, and this is an important but, other heavily populated, well-instrumented regions of the world exist. Europe has its own fireball monitoring networks. Japan and South Korea have sophisticated meteor observation programs. India and China together represent over 2.5 billion people, many of whom have smartphones. If we were simply seeing a hemisphere-wide or global increase, some of that signal should be leaking through from these other regions. The Germany event is there. But beyond that early outlier, the concentration holds. Stefan Burns flagged this as a highly localized pattern within his broader analysis, and the geometric interpretation he offered is worth considering. If Earth is rotating through a structured region of space, a debris field or stream that is not uniform in all directions but instead has a preferred orientation relative to Earth's orbital path, then the face of the planet that is sweeping forward into that material at any given time would receive the bulk of the incoming flux. Think of it like a car driving through rain at an angle. The windshield gets far wetter than the rear window. If the incoming material has a preferred approach geometry, North America's position relative to that geometry during March 2026 could produce exactly the concentration pattern we're observing. This is speculative at the level of geometric modelling. We do not have the orbital data on enough of these events to confirm a preferred approach direction with high confidence. But the clustering is real, it is anomalous, and it adds one more independent line of evidence to a case that keeps accumulating lines of evidence. When randomness is driving a phenomenon, the geographic distribution tends to spread out over time towards something uniform. When structure is driving a phenomenon, concentration persists and sometimes sharpens. If randomness were behind all of this, it would not concentrate like this. Part 6. Why? More cameras. Fails. The first explanation that most scientifically minded people reach for when confronted with the March 2026 fireball numbers is also, on its face, the most reasonable one. We are seeing more reports because we have more ways to generate reports. More smartphones means more witnesses who can instantly file an observation to online databases. More dash cams means more passive video capture. More all-sky camera networks means more automated detection. The infrastructure for seeing and reporting fireballs has expanded substantially over the past 15 years, and it is genuinely plausible that some of what looks like an increase in events is actually an increase in our ability to detect the same underlying rate of events. The problem with this explanation is that it runs directly into a wall of timing. Smartphone penetration in the United States and Europe reached saturation levels around 2014 and 2015. The growth curve for smartphone ownership in the regions that dominate the American Meteor Society's reporting base flattened out roughly a decade ago. If smartphone proliferation were going to produce a sudden surge in fireball reports, that surge should have happened around 2014 or 2015, and it did not. The AMS database has been broadly stable since 2011, with gradual year-over-year changes rather than sudden spikes. There is no mechanism by which a technology that saturated the market a decade ago produces a dramatic spike in detection today. The timing does not work. But there is a more decisive argument against the reporting bias explanation, and it comes from the very same distributional analysis we examined in the last section. Think about what reporting bias actually does to a dataset. If you have more reporters, you capture more events across the board. You pick up more of the faint ones that previously went unnoticed. You pick up more of the moderate ones that previously had only 1 or 2 witnesses. You pick up more of everything, proportionally, because your net is bigger and your mesh is finer. The effect of reporting bias is to raise the entire distribution roughly uniformly. Like adding water to a container, the level rises at every point. What the March 2026 data shows is not that. The low-end events, 10 to 24 witnesses, the small and dim fireballs, have not meaningfully changed. Their counts are normal, their distribution is stable. If the net were bigger, those would be the first things it would catch more of, but they are not changing. Only the high-end events are surging. Only the large, bright, energetic, deep-penetrating objects are appearing in numbers that have no historical parallel. That is not what reporting bias looks like. Reporting bias inflates everything. What we are seeing is selective inflation of the most physically significant events. That pattern has a name in statistics, and the name is not artifact. The name is signal. The more you try to explain March 2026 away with cameras and smartphones, the worse the numbers look for that explanation. And if you cannot explain it away, you have to explain it, which means confronting what the data is actually pointing at. Part 7. The Equinox Effect Myth. There is a real phenomenon called the vernal equinox enhancement, and it is worth understanding correctly because it is the second standard explanation for increased spring meteor activity, and like the reporting bias argument, it collapses under even modest scrutiny when applied to the current numbers. Here is the actual mechanism. As Earth orbits the Sun, its orientation relative to the ecliptic plane, the broad disk of space where most solar system debris orbits, changes over the course of the year. Around the vernal equinox in late March, Earth is oriented in a way that increases its effective cross-section for intercepting sporadic meteoric material. The dawn terminator, the leading edge of Earth as it sweeps through its orbit, is tilted toward a particularly debris-populated region of the ecliptic. You're more likely to get hit by a rock you're driving toward than one that has to catch up to you, and at equinox Earth's geometry is slightly more favourable for these head-on encounters. This is a documented, well-characterised effect. It is also a modest effect. The numbers that planetary scientists put on it are in the range of 10 to 30% above the non-equinox baseline. It shows up consistently in long-term databases as a gentle seasonal ripple, reliable and predictable. It is the kind of effect that researchers use to validate their datasets. If you run a fireball detection system for a few years and you do not see the equinox enhancement, something is wrong with your data collection. It is that regular. Now do the math. If your baseline is 2 significant fireball events per month, a 30% equinox enhancement gives you 2.6 events. Round up generously to 3. We are at 10. The equinox effect, even at the absolute upper edge of its documented range, gets you to approximately a quarter of what March 2026 is showing. It cannot account for the other 70% of the anomaly. It cannot explain the sonic boom rate. It cannot explain the distribution shift toward high witness events. It cannot explain the fragment recoveries. The equinox effect is a 10 to 30% phenomenon being asked to explain a 300% anomaly, and that is not a gap that scientific charity can bridge. What makes the official explanation particularly frustrating is that it is not wrong in a vacuum. It is wrong as a sufficient explanation. Yes, it is equinox season. Yes, that adds a small increment of expected activity, but that small predictable increment is swamped by an order of magnitude more anomaly than it could ever account for. Using the equinox effect to explain March 2026 is like explaining a forest fire by pointing out that it is summer and it is warmer in summer. Technically true, completely inadequate. If it is not cameras and it is not the season, then the explanation has to be structural. Something about the actual material environment that Earth is moving through has changed, and the shape of that change, the way it concentrates in the upper end of the energy distribution, the way it is producing physically dense objects that survive deep into the atmosphere, the way it is leaving fragments on the ground, that shape points toward a specific kind of structural cause. Part 8. The radiant that is not there. Every recognized meteor shower has a radiant. That is the point in the sky from which all the meteors in the shower appear to originate. A perspective effect, like the way railroad tracks appear to converge at a vanishing point in the distance. When Earth passes through a comet's debris trail, all the particles in that trail are moving in roughly the same direction, and when you trace their atmospheric paths backward, they all point to the same place. The Perseids radiate from Perseus. The Leonids radiate from Leo. You can plan a meteor shower viewing event around the radiant rising above the horizon, because the geometry is predictable and consistent. When researchers try to apply this analysis to the March 2026 events, taking the calculated entry trajectories of the confirmed high-energy fireballs and tracing them back to find a common origin point, what they find is not a radiant. What they find is scatter. The right ascension and declination plot of the event radiance does not converge cleanly on any single location in the sky. There is a weak clustering in the general direction of the Anthelian source, a broad background concentration of sporadic meteors that comes roughly from the direction opposite the Sun, but the clustering is not tight enough, and the events are not consistent enough with each other's trajectories to say that Earth is passing through a single coherent debris trail. This is one of the most important and most under-discussed aspects of the entire anomaly. If March 2026 were a classic meteor shower, a known, catalogued stream that Earth happens to pass through every year, it would have a radiant. The absence of a clear radiant is not a negative result that merely fails to confirm one hypothesis. It is a positive result that actively excludes a specific category of explanation, namely the Earth passed through a known annual stream explanation. We are not in the Perseids. We are not in any identified recurring shower. The orbital distribution of the incoming material does not look like a single coherent debris trail. What it does look like, provisionally, are two things that are not mutually exclusive. The first is a diffuse debris field, a region of space where material is distributed across a broader volume rather than concentrated along a linear trail, producing arrivals from a range of directions that scatter when you try to trace them back to a point source. The second is overlapping contributions from multiple independent streams that happen to all be elevated at the same time, producing a blended signal that looks incoherent because it genuinely is incoherent, the sum of several signals rather than the output of one. Either way, the absence of a clean radiant tells you that this is not a phenomenon that fits into the existing taxonomy of recognized annual meteor activity. You are dealing with something that does not have a slot in the catalogue. And when you are dealing with material that does not have a slot in the catalogue, that is arriving from diffuse or multiple directions, that is skewed toward high energies and dense compositions, what you are describing, whether you're ready to say the words yet or not, is a debris environment. A region of space with elevated material density, structural complexity, and no neat origin story. Earth is moving through something, and the something does not have a name yet. Part 9. The energy scaling problem. Pull out the three events that most clearly define what is anomalous about March 2026, and lay their energies side by side. The Ohio event on March 17th, approximately 250 tons of TNT equivalent, released in the middle of the afternoon over a populated state. The Texas event on March 21st, approximately 26 tons of TNT equivalent, smaller but still firmly in the significant event tier. And earlier in the quarter, a Pacific Ocean entry that added its own data point to the growing energy distribution. When you plot these numbers against the historical distribution of fireball energies, the size-frequency relationship that planetary scientists have built from decades of satellite and seismic detection data, what you find is that the high-energy tail of the distribution has gotten fatter. There are more events at the high end than the historical model predicts. For context, the 250-ton TNT equivalent Ohio event is in the same energy range as a small tactical nuclear weapon. Not a city killer, not a civilization-ending event, but substantially more energetic than the kind of meteor that makes the news once a year. The Chelyabinsk event in 2013, which shattered windows across a Russian city and injured over 1,000 people, released energy in the range of several hundred kilotons of TNT, orders of magnitude above Ohio. But Ohio is not trying to be Chelyabinsk. Ohio is trying to be a data point in a distribution, and as a data point, what it tells you is that the size of incoming objects is shifted upward from the typical background. The physics here is straightforward once you understand the size-frequency relationship. In any natural population of objects, asteroids, meteoroids, debris fragments, larger objects are rarer than smaller ones, and the relationship follows a predictable power law curve. For every object of a certain size, you expect some larger number of objects half that size, and an even larger number a quarter that size, and so on. This curve is well characterized for Earth-crossing material from historical data. When the observed distribution deviates from the expected curve by producing more large events relative to small events, it means the incoming population is not drawn from the same statistical distribution as the baseline. Something has changed about what is hitting us, not just how often we are detecting it, and that something, when translated from statistical language into physical language, points toward a source that is not the diffuse background of random interplanetary debris. The background population of sporadic meteors follows the expected distribution closely. What produces a distribution skewed toward larger objects is fragmentation, a larger body that has recently broken apart and is distributing its pieces into Earth-crossing orbits. The size distribution of fragments from a recent breakup event looks different from the smooth background, because fragmentation is a violent process that produces a specific spectrum of piece sizes. The energy distribution of March 2026 has that signature. Not definitively, the dataset is not large enough to be certain, but the shape is pointing somewhere. Part 10. The Statistical Wall. 4.5 sigma. It is worth spending a moment on what that number actually means in practice, because statistics has a way of being both deeply rigorous and deeply misused at the same time, and the claim here is specific enough to deserve careful treatment. Numbers like this get thrown around in science communication with a confidence that often outpaces their actual meaning, and the last thing this story needs is an overstatement that gives skeptics an easy exit. So let us be precise, because the precise version is already extraordinary enough without any embellishment. A sigma value, also called a standard deviation, measures how far an observation is from the expected mean of a distribution, in units of that distribution's natural spread. Think of it this way: if you measure the height of 10,000 adult men and plot those heights on a graph, you get a bell curve centered around some average value. 1 sigma covers the range that includes roughly 68% of all the measurements, the tallish and shortish people who are basically normal. 2 sigma covers about 95%. 3 sigma covers 99.7%. By the time you get to 4 sigma, you're talking about the extreme edges of the distribution, the people who make professional basketball scouts do a double take. 4.5 sigma means that the March 2026 fireball count sits 4.5 standard deviations above the mean of the historical distribution. To translate that into probability language, under a stable random system, you would expect to see a fluctuation this large or larger approximately once in every 140,000 similar time periods. 140,000 months. That is roughly 11,600 years. To put that in perspective, 11,600 years ago, humans were still in the early Neolithic period. Agriculture had barely been invented. The pyramids were not yet a thought in anyone's mind. If you had been running a fireball detection system since the beginning of organized human civilization and recording monthly counts faithfully every single month, you would statistically expect to see a spike like March 2026 roughly once in that entire span of recorded history. That is not impossible. Let me be direct about that, because this is where statistical claims most often get mangled in the retelling. 4.5 sigma is not a violation of physics. Random systems do produce extreme outliers. If you flip a fair coin long enough, you will eventually get 20 heads in a row, and when you do, the coin is not broken and the universe has not malfunctioned. Rare things happen. The rarity of a thing is not proof that something caused it beyond ordinary chance. But, and this is the critical but, the key word in that entire calculation is stable. The probability estimate of 1 in 140,000 assumes that the underlying rate has not changed. It assumes that you are sampling from the same distribution in March 2026 as you were in every previous March. It assumes the system generating the data is the same system it has always been. That assumption is doing an enormous amount of work in the official dismissal of these numbers, and it is an assumption that deserves to be interrogated rather than inherited. If the underlying rate has changed, if something about Earth's near-space environment has genuinely shifted, then the probability calculation is not wrong, exactly. It is inapplicable. You cannot use the statistics of one system to evaluate the outputs of a different system. That would be like using the historical weather records of Phoenix, Arizona, to evaluate whether the rainfall in Seattle is unusual. The math works perfectly and means absolutely nothing, because you are applying the wrong baseline. What 4.5 sigma tells you, precisely and usefully, is this. If nothing has changed, this observation is extraordinarily unlikely. That statement is a fork in the road, not a conclusion. Either you accept that you are witnessing an extraordinarily unlikely fluctuation in an unchanged system, or you accept that the system has changed. Those are the two options the number gives you, and the number alone cannot tell you which one is correct. For that, you need everything else. And here is where the story stops being about a single number and starts being about a pattern of numbers that should not all be breaking simultaneously if randomness were the only thing driving the anomaly. The sonic boom rate among the largest first quarter 2026 events is anomalous, not slightly elevated, but sitting at 79% when prior elevated years were producing lower rates against lower overall counts. The witness count distribution is anomalous, with the average per event running at nearly 3 times the previous monthly record, concentrated entirely in the high-energy upper tier, while the lower tiers remain flat. The energy scaling of individual events is anomalous, the size-frequency distribution of incoming objects showing a fatter high-energy tail than historical baselines predict. The fragment composition across 3 separate recovery sites is unusual, eucrate-like material from what appears to be a common Vesta-derived source, appearing twice within 9 days at energy scales where eucrate falls are already statistically rare. The geographic concentration is notable, a clustering of events over North American territory that persists beyond what population density and reporting infrastructure alone can fully account for. Now here is the statistical argument that the 4.5 sigma headline number does not capture, and it is arguably more powerful than the headline. These independent signals are not different readings of the same underlying number. They come from different data sources, satellite detection systems, ground-based witness networks, seismic and infrasound arrays, physical fragment recovery and mineralogical assessment, orbital trajectory reconstruction. They reflect different physical phenomena, event frequency, atmospheric penetration depth, energy deposition, material composition, arrival geometry. They are connected by the same underlying physical reality, but they are measured by completely separate methodologies that have completely separate error profiles and completely separate potential failure modes. The probability that all of them fluctuate simultaneously in the same direction by independent chance is not 4.5 sigma. It is the product of several independent low-probability events occurring together at the same time in the same coherent direction. Multiply several small probabilities together and you get a number that starts to approach the kind of values that make coincidence feel like an increasingly uncomfortable word to use in polite scientific company. Each individual anomaly might be explainable in isolation with enough creative invoking of natural variation. All of them together, pointing the same way, at the same time, measured by independent methods, is a different kind of claim. That convergence is the actual statistical argument, and it is more compelling than any single sigma value. When a single metric breaks, the scientifically responsible response is to seriously consider instrument error, reporting bias, or natural variation. Those are real phenomena, and they should always be the first places you look. When 2 metrics break, you start looking for a common cause but remain open to coincidence. When 5 or 6 independent metrics break simultaneously in a coherent direction, when the count is up, the energy is up, the penetration depth is up, the fragment recovery rate is up, and the geographic pattern is concentrated. The most parsimonious explanation, the one that requires the fewest separate coincidences to be true at the same time, is that something real has changed in the underlying system generating all of those measurements. This is not proof. Science does not traffic in proof. It traffics in evidence, and in the weight of evidence, and in the question of which explanation requires you to believe fewer improbable things simultaneously. The weight of evidence in March 2026 is not pointing toward a statistical ghost. It is pointing toward a physical change in what Earth is moving through, and the nature of that change, its structure, its origin, its implications for what comes next, is what every other section of this story has been building toward. When multiple independent metrics break at once, randomness stops being the best explanation. Something else does. Part 11. The debris stream hypothesis. Earth does not travel through empty space. It sounds obvious when you say it out loud, but it is the kind of fact that most of us carry around as abstract background knowledge without ever really sitting with its implications. We picture our planet moving through the solar system the way a ship moves through open ocean, surrounded by vast, dark, essentially empty distance, with the occasional rock drifting past at a safe remove. That picture is not wrong in its broad strokes. Space is genuinely enormous, and the distances between objects are genuinely vast. But the volume of the solar system that Earth sweeps through over the course of its orbit is not sterile. It is populated with dust, with pebbles, with boulders, and in some places with dense concentrations of debris left behind by events that were violent enough to scatter material across millions of kilometers of orbital space, comets that broke apart under tidal stress or solar heating, asteroids that collided and shattered into families of fragments. Parent bodies nudged by Jupiter's immense gravitational influence into orbits that brought them, or their remnants, progressively closer to the inner solar system over millions of years of slow orbital evolution. The resulting structures, debris streams, dust trails, fragmentation families are the fingerprints of those violent events. They are the crime scene tape left behind after something catastrophic happened, and they persist long after the events that created them, sometimes for millions of years, slowly spreading and diffusing but never fully disappearing. Every time Earth passes through one of these structures, we call it a meteor shower if it is gentle, and something considerably less poetic if it is not. The leading physical explanation for what March 2026 is showing, the one that most consistently accommodates the full spread of anomalies without requiring exotic assumptions or classified technology or interstellar intervention, is that Earth has entered, or is currently in the process of traversing, an unusually dense region of one of these debris streams, not a stream we know about, not a stream that is in the annual catalogue, something that either has not been characterised yet, or has not been characterised at the density and composition that Earth is currently intersecting. To understand why this explanation is so compelling, it helps to understand how a stream actually forms at the mechanical level, and why the streams that matter most for planetary hazard are the ones that deviate from the tidy textbook description. When a comet makes a close pass to the Sun, the heat causes volatile materials embedded in its nucleus, water ice, carbon dioxide, complex organic compounds, to sublimate directly from solid to gas, jetting outward and carrying with them particles of dust and rocky debris that had been locked inside the nucleus since the early solar system. Some of that material forms the visible tail that makes comets so striking from Earth. But a significant proportion of it distributes itself along the comet's orbital path, spreading both ahead of and behind the nucleus as the comet continues its orbit. Under the influence of radiation pressure from sunlight, the Poynting-Robertson drag effect, and the subtle but cumulative gravitational perturbations of the planets, Jupiter especially, this material gradually diffuses into a broad, elongated structure that follows the comet's orbital track through space. Over many orbits and many centuries, that structure spreads into something diffuse enough that Earth can intersect it at predictable points in its own orbit, producing the reliable annual meteor showers that appear in every sky-watching calendar. The Perseids in August, the Leonids in November, the Geminids in December, these are all Earth crossing the debris trails of known parent bodies on a schedule precise enough that astronomers can predict their peak dates years in advance. But here is the part that the standard meteor shower description tends to leave out, because it complicates the clean annual event narrative. Streams are not uniform. They are not smooth, evenly distributed tubes of debris with consistent density throughout. They have structure. They have density variations, clumps, knots, regions where material is significantly more concentrated than the surrounding stream, often because a major fragmentation event happened relatively recently, and the resulting debris has not yet had sufficient time to spread out and homogenize with the older stream material. A fresh fragmentation event within an existing stream is like dropping a handful of gravel into a river. The gravel starts concentrated at the point of entry, and only gradually disperses downstream. If Earth happens to intersect the stream at or near that concentrated region, before the dispersal is complete, what it encounters is not a gentle annual shower, it is something considerably more energetic. And critically, these concentrated regions can contain objects across the full-size range of the original fragmentation event, from fine dust all the way up to fragments that, by any reasonable definition, qualify as small asteroids. The size distribution within a debris stream is not capped at some safe upper limit. It reflects whatever the parent body or fragmentation event produced, and parent bodies in the asteroid belt can produce fragments hundreds of meters across. Those fragments do not announce themselves. Low reflectivity, dark-surfaced rocky material in a debris stream is extraordinarily difficult to detect against the background sky until it is already very close to Earth, at which point the detection lead time collapses to hours or days rather than years. The connection from this physics to March 2026 is not circumstantial. It is direct and it is specific. A non-uniform debris stream with a recently concentrated clump would explain, simultaneously and without contradiction, every major anomaly in the dataset. The lack of a single clean radiant makes immediate sense if the incoming objects are distributed across a broad stream structure rather than a single tight trail. Objects arriving from a range of positions within a wide stream will have slightly different approach directions, and when you trace those directions back, you get scatter rather than convergence. The shift in the size distribution toward larger, more energetic events makes sense, because concentrated regions of streams associated with recent fragmentation events contain a higher proportion of large fragments relative to the diffuse background sporadic population. The elevated sonic boom rate makes sense because dense, rocky fragments derived from asteroid-like parent bodies are precisely the kind of material that has the structural integrity to survive deep atmospheric penetration rather than ablating away quietly in the upper mesosphere. And the temporal concentration, the fact that the anomaly is strongest right now, in this specific window, rather than being spread evenly across the year, makes sense because Earth is moving through the stream at a specific point in its orbit, and like any crossing of a finite structure, it has a beginning, a densest middle, and eventually an end. The closest historical analogue for this kind of scenario, at the scale we are discussing, is the Taurid complex. The Taurids are a broad, diffuse stream associated with Comet Encke and a family of related objects, and they occupy a special place in the meteor research literature precisely because they behave differently from most annual showers. Their fireball rate, the proportion of events that are large, bright and energetic rather than faint and forgettable, is consistently higher than the background sporadic population. Every few years, when Earth's orbit carries it through a denser clump within the broader Taurid structure, the rate of significant fireball events increases noticeably, and the average event energy goes up. Researchers have been arguing for decades that the Taurid complex contains coherent clusters of large dark objects, potentially in the tens to hundreds of meters range, that have not yet been individually catalogued by near-Earth object surveys, partly because they are dark, partly because they are embedded in a stream of surrounding material that complicates detection, and partly because current survey programs are optimized for finding isolated objects in clear sky rather than objects embedded in debris environments. The current situation rhymes with that description in a way that is difficult to ignore. Earth may be passing through an analogous structure, a dense, partially catalogued stream with a higher proportion of large fragments than the background population, a concentration of material that has no existing entry in the annual shower catalogue, and a geometric relationship to Earth's current orbital position that explains why this is happening now rather than last year or next year. The difference from the Taurids is significant but not reassuring. The Taurids, whatever their hazards, are at least known. They have a name, a characterized orbit, a family of associated objects, and decades of observational data. Whatever Earth may be crossing right now does not have any of those things. It is unnamed, it is uncharacterized, and by definition, an uncharacterized stream is one whose full content, including the upper end of its size distribution, remains unknown. There is one implication that follows from the debris stream hypothesis, with a logical directness that the physics does not allow you to sidestep. It follows from the structure of streams, from the way material distributes itself within them, and from the basic mechanics of what Earth encounters first when it enters a concentrated region. It is the implication that makes the March 2026 anomaly something other than a record to be filed and forgotten. It is the part of this story that deserves to be told without exaggeration, but also without euphemism. Part 12. The Scouts Come First Principle. Within a debris stream, not all objects behave the same way. This is the sentence that changes the entire character of the March 2026 story. Not the fireball count, not the sigma value, not even the fragment recoveries. Those numbers establish that something anomalous is happening. This principle establishes what the anomaly might be telling us about what comes next. And it is grounded not in speculation but in the same orbital mechanics that planetary scientists use to predict meteor shower peak dates and model the long-term evolution of debris fields. It is, in that sense, the most uncomfortable kind of fact, a boring one. The physics starts with a size-dependent response to force. The smallest particles in a debris stream, the dust grains, the sand-sized fragments, the pebbles, are subject to two non-gravitational forces that act on them with an efficiency that larger objects simply do not experience to the same degree. The first is radiation pressure, the direct push exerted by photons of sunlight striking a surface. It is a real force, measurable and well characterized, and it acts on every object in the solar system. But its effect scales with the surface area of the object it is pushing against, while the inertia that resists that push scales with the object's volume. Surface area grows as the square of an object's size. Volume grows as the cube. This means that as objects get larger, their volume, and therefore their inertia, grows faster than their surface area. A grain of dust gets pushed around by sunlight quite effectively. a boulder barely notices. The second force is the Poynting-Robertson effect, a subtler phenomenon in which the absorption and re-emission of solar radiation by an orbiting particle causes it to gradually lose orbital energy and spiral inward toward the Sun over time. Again, this effect is most pronounced for small particles and becomes progressively negligible as object size increases. Together, radiation pressure and Poynting-Robertson drag act as a sorting mechanism within debris streams, preferentially moving small material relative to large material over the timescales of centuries and millennia that streams persist. The result of this differential sorting is a spatial structure within the stream. Small objects, more responsive to these forces, migrate outward from the stream's central orbital path. They spread into the leading and trailing regions of the stream, the edges that Earth encounters first and last during a crossing. Large objects, heavier and far less responsive to radiation forces, are comparatively unaffected by this migration. They remain gravitationally anchored closer to the centre of the stream's orbital path, in the denser core regions where the stream's mass is most concentrated and where the original fragmentation event deposited the bulk of its largest products. Think of it like a river delta sorting sediment by size. The finest particles get carried furthest by the current. The heaviest material settles closest to the source. In a debris stream, the current is light itself, and the settling happens over astronomical timescales, but the outcome is the same. Size-dependent segregation produces a stream with a leading edge populated by the lightest, smallest material, and a core populated by whatever large fragments the original disruption event produced. This ordering has a specific and unavoidable geometric consequence for what Earth encounters as it moves through a crossing. The first material Earth intercepts, at the leading edge of the stream, is biased toward the smaller, lighter objects that radiation forces have pushed outward over time. As Earth's orbit carries it deeper into the stream, as the crossing progresses from leading edge toward the denser central regions, the character of the incoming material changes. The proportion of larger, more massive, more structurally coherent fragments increases. The average energy per event goes up. The smallest stuff comes first. The biggest stuff, if it exists within the stream, is deeper in. Now apply that principle directly to what March 2026 has produced, and sit with the implication for a moment before reaching for either alarm or reassurance. The events we have documented this month are not small. The Ohio bolide on March 17th carried an estimated mass of approximately 7 tons and released energy equivalent to roughly 250 tons of TNT. The Texas event on March 21st added another confirmed sonic boom-producing entry. Fragments physically recovered from 3 separate sites show compositional characteristics consistent with dense, igneous, asteroid-derived material, not the fragile, loosely bound carbonaceous material that makes up a large fraction of the background sporadic population and tends to ablate high in the atmosphere without leaving anything behind. These are robust objects. By any measure drawn from the historical fireball record, the material arriving in March 2026 sits well above the median in terms of mass, density, and atmospheric penetration depth. And the question the debris stream physics asks quietly without drama, simply as a consequence of the sorting mechanism we just described, is this. If the objects arriving at the leading edge of a stream crossing are already this large, what does the interior of the stream contain? There are historical cases that give this question a concrete frame of reference, and the most instructive one is also the most sobering. On June 30th, 1908, something entered the atmosphere over a remote region of Siberia near the Podkamennaya Tunguska River and released energy estimated between 10 and 15 megatons of TNT equivalent, roughly 1,000 times the energy of the Hiroshima bomb. The object, which never reached the surface intact but detonated as an airburst at an altitude of approximately 5 to 10 kilometers, flattened an estimated 2,000 square kilometers of Siberian forest. Trees were knocked flat in a radial pattern across an area larger than Greater London. The shock wave was detected by barometric stations across Europe. Had the entry occurred 4 hours later, as Earth's rotation carried it westward, the ground track would have passed over St. Petersburg. The warning time for the Tunguska event was effectively 0, not because detection technology was inadequate, though it was by modern standards, but because nothing preceded it. No notable precursor events in the days or weeks before June 30th, 1908 suggested that an object of that energy scale was incoming. The event arrived without scouts, or if scouts existed, they arrived unobserved. The The object itself, estimated at between 50 and 80 meters in diameter, depending on which atmospheric entry model you apply, was either a genuinely isolated sporadic that happened to be large, or it was part of a stream structure whose leading edge material simply did not produce events detectable with the instrumentation of that era. We were not watching carefully enough in 1908 to know which of those was true. The Tunguska event landed in a part of the historical record where the context is permanently missing. What we know now that nobody in 1908 could have known is that debris streams are stratified. The structure we described, small material on the leading edge, large material in the core, is not a theoretical construct. It is a documented physical consequence of well-understood orbital mechanics, observed in the behaviour of known streams and confirmed by the mathematical models that planetary scientists use to reconstruct stream evolution. The scouts come first, and when you're watching the scouts arrive, when you're watching 7-ton bolides produce daylight fireballs over Ohio, when you're watching sonic booms rattle windows every 3 days, when you're watching Euclid fragments get picked up off the ground in Texas, you're watching the leading edge do exactly what leading edges do. Which means you're not necessarily at the most intense part of the crossing. You may be, in the most literal geometric sense, just inside the door. This is the moment where intellectual honesty demands a very specific kind of precision, because the gap between physically possible and predicted is enormous, and collapsing that gap in either direction, toward full certainty of danger or full certainty of safety, serves no one. This is not a prediction. No model currently in the public domain has identified a specific large object on a confirmed Earth-intersecting trajectory embedded in whatever structure is producing the March 2026 anomaly. The absence of such a detection is meaningful, even accounting for the survey gaps we discussed earlier. The most likely scenario remains that Earth is traversing a concentrated but finite debris region, whose largest members are in the bolide to small asteroid size range. Significant, historically unprecedented in observed rate, but not civilization scale. What the physics provides is not a prediction of what will happen. It provides a framework for interpreting what is already happening. And within that framework, the March 2026 fireball data is consistent with the leading edge phase of a stream crossing. Consistent with, not confirmed by. The distinction matters enormously in both directions. It means we should not panic, and it means we should not look away. Consistency with a hypothesis is not confirmation of it, but it is also not nothing, and the difference between those two statements is exactly the width of the door we may have just stepped through. Part 13, the Taurid Resonant Swarm Parallel. In the 1990s, two researchers decided to take seriously a possibility that most of their colleagues preferred to leave politely unexamined. Victor Klube was a British astronomer based at Oxford. Bill Napier was an astrophysicist with a career spanning several of the United Kingdom's most prominent research institutions. Together, they published a body of work that made an argument both specific and deeply uncomfortable. The inner solar system is significantly more hazardous than mainstream planetary science was prepared to acknowledge, and the reason it is more hazardous is not random background noise from the general asteroid population. It is something more structured, more periodic, and in some ways more difficult to defend against precisely because of how difficult it is to see coming. Their argument centered on the Taurid complex, the broad, diffuse debris structure associated with Comet Encke and its extended family of related short-period comets. The Taurids are familiar to any amateur astronomer who has spent a clear November night watching the sky. They produce a gentle, reliable shower in autumn, nothing spectacular by meteor shower standards, notable mainly for the occasional bright fireball that stands out against the background of fainter streaks. As annual showers go, they are considered moderate at best. What Klube and Napier argued is that this familiar, unassuming shower is the visible surface of something considerably more significant underneath. Their specific proposal was this: embedded within the broader Taurid complex is a resonant swarm, a population of large, dark, low reflectivity objects locked into an orbital resonance with Jupiter. Orbital resonance in this context means that these objects complete a specific number of orbits around the Sun in the same time that Jupiter completes a specific number of its own orbits, creating a gravitational rhythm that repeats with clockwork regularity. Objects caught in resonance do not simply drift through the solar system on independent trajectories, they get herded. Jupiter's periodic gravitational influence nudges them back toward the same orbital configuration every few years, trapping them in a predictable pattern and preventing the gradual orbital evolution that would otherwise scatter them away from Earth-crossing paths over geological time. The resonance is in effect a cage, and the objects inside it keep returning to the same neighbourhood of the inner solar system on a schedule determined by the mathematics of orbital mechanics rather than by chance. The objects Klube and Napier were describing are not the kind of thing that shows up easily in a standard asteroid survey. They are dark, low-albedo bodies that reflect a small fraction of the sunlight that strikes them, making them far dimmer against the background sky than a similarly sized rocky asteroid with a brighter surface. They are relatively small by the standards of the large, named asteroids that dominate public awareness of the impact hazard, not the multi-kilometre bodies that planetary defence researchers focus most of their attention on, but objects in the 100-metre to kilometre range that occupy a more awkward middle ground. Too large to burn up harmlessly in the atmosphere, too small and too dark to be efficiently detected by survey programs designed with different priorities, and they are embedded in a stream of surrounding material, the broader Taurid debris, that provides a kind of camouflage, making individual objects harder to isolate and track than they would be in empty sky. The Klube and Napier hypothesis was not welcomed with open arms by the mainstream planetary science community when it was first published. It required accepting a level of undetected hazard that sat uncomfortably against the general trajectory of the field, which was moving toward increasingly confident characterization of the near-Earth object population. The idea that a significant population of dangerous, periodically returning objects was hiding inside a known but understudied stream structure felt, to some critics, more like catastrophism than careful science. The reception was sceptical, sometimes dismissive, occasionally hostile in the way that heterodox ideas in established fields tend to attract hostility when they challenge the prevailing sense of how well understood something is. But the work was serious enough and specific enough to generate ongoing research rather than simply fading away. And over the subsequent decades, pieces of the Klube-Napier framework were confirmed or supported by independent observations that had nothing to do with the original authors. The Taurid complex does demonstrably produce a higher proportion of large, energetic fireball events than the background sporadic population. This is not contested. Jupiter resonance does trap debris in predictable orbital configurations. This is standard celestial mechanics, observable in the asteroid belt's Kirkwood gaps and in the behaviour of multiple known comet families. Dense concentrations of dark material embedded within broader streams do remain largely undetected by current survey programs. This is an acknowledged limitation of existing near-Earth object catalogues, explicitly noted in planetary defence assessment documents published by NASA and the European Space Agency. The surveys we have built are extraordinary tools. The Catalina Sky Survey, Pan-STARRS, the Atlas Network, between them, they have catalogued thousands of near-Earth objects and substantially completed the inventory of objects large enough to cause global catastrophe. But they are optimised for a specific kind of target: bright, isolated objects moving against clear sky in the main belt or in well-characterised Earth-crossing orbits. Dark objects are harder. Objects embedded in streams are harder. Sub-kilometre bodies in the 100-metre to 300-metre range, precisely the size class that Klube and Napier identified as the core hazard within the Taurid swarm, remain incompletely catalogued even by the best current programs. The incompleteness is not a failure of effort. It is a consequence of physics, observational geometry, and the allocation of finite resources toward the most tractable targets. Now bring all of that history forward to March 2026 and be precise about what is and is not being claimed. The connection between the Klube-Napier framework and the current fireball anomaly is structural rather than direct. We are not claiming that the March 2026 events represent the Taurid resonance swarm making an appearance. The Taurids are an autumn phenomenon for Earth. Their primary activity window runs from October through November, driven by the specific geometry of Earth's orbit relative to the Taurid stream's orbital plane. March is not Taurid season. Whatever Earth is currently moving through, it is not the Encke family debris trail that Klube and Napier spent their careers analysing. What the Taurid parallel provides is something more valuable than a direct identification. It provides a proof of concept. It demonstrates with a specific and historically documented case that the following scenario is not exotic, not fringe, not invented to explain an inconvenient anomaly. A dense, partially dark, Earth-crossing debris cluster, embedded within a broader stream structure, not fully catalogued by current survey programs, capable of producing elevated rates of large energetic fireball events when Earth's orbit intersects it. That scenario has a name. It has a paper trail going back 30 years. It has observational support from independent research programs that had no stake in validating Klube and Napier's specific conclusions. It is, in the most precise sense of the phrase, a known unknown, a category of hazard that the planetary science community has formally acknowledged exists, even if the specific instances of it remain incompletely mapped. What is being suggested about March 2026 is narrower and more specific than a general invocation of the Taurid analogy. It is this: a similar kind of structure, a concentrated, dark, partially undetected debris cluster in an Earth-crossing orbit, may exist that current surveys have not yet characterized, and Earth may be crossing it right now. Not the Taurids, not Enka. Something else, something without a catalogue entry, something whose existence we are potentially inferring from its effects, rather than from direct detection of the objects themselves. This is how a large fraction of important discoveries in planetary science actually happen. You see the gravitational effects before you see the body. You see the debris before you identify the parent. You see the stream crossing before you map the stream. The history of solar system astronomy is full of cases where the signature arrived before the explanation, and the explanation only came together after researchers were willing to take the signature seriously rather than explaining it away. The absence of a known stream in the catalogue does not mean the absence of a stream in space. It means the absence of a catalogued stream. Those two statements describe very different situations, and collapsing them into each other, treating "we haven't found it" as equivalent to "it isn't there," is an error with a specific name in the philosophy of science. It is called arguing from ignorance, and it is particularly dangerous in planetary defense contexts, where the cost of being wrong is not an embarrassing retraction in a journal, but something considerably more consequential. The difference between a catalogued stream and an uncatalogued one is not a difference in what exists in space. It is a difference in what exists in our databases. And the next several weeks of observation data, the April fireball rates, the continued fragment analysis, the ongoing radiant mapping of March 2026 trajectories may begin to close that gap, or they may deepen it. Either answer will be informative, and only one of them will be comfortable. Part 14. The Interstellar Angle. On July 9th, 2025, an alert went out through the astronomical community that had a specific quality of excitement attached to it, the kind that comes not from discovering something expected, but from confirming something that, until recently, most astronomers had assumed they might never see in their careers. An object designated C/2025-1 had been detected moving through the solar system on a hyperbolic trajectory. Hyperbolic, in orbital mechanics, means the object's velocity exceeds the local escape velocity of the Sun's gravitational field. It is not in an orbit. It is on a trajectory, a one-way passage through the solar system that began somewhere in interstellar space, will reach its closest approach to the Sun, and will then continue outward and away, never to return. The Sun's gravity will bend its path but cannot hold it. It came from somewhere else. It is passing through our neighbourhood, and it will leave. The object was given the informal designation 3I Atlas, the 3I standing for Third Interstellar Object, Atlas for the telescope network that first detected it. It is only the third confirmed interstellar visitor ever identified passing through our solar system. The first was Oumuamua, detected in 2017, a strange, elongated, tumbling object that defied easy classification and generated years of scientific debate about its nature, its composition, and in some corners of the research community, its origin. The second was Borisov, detected in 2019, a more straightforwardly cometary object that outgassed as it approached the Sun and behaved, at least superficially, like a comet from another stellar system. 3I Atlas is the third. Each one has arrived with its own set of unanswered questions, and 3I Atlas is no exception. The reason 3I Atlas enters the March 2026 story is not, on its face, a straightforward connection. It requires a specific kind of contextual reasoning that is worth unpacking carefully, because it is easy to draw this connection too tightly, and equally easy to dismiss it too quickly, and neither of those responses does justice to what the data actually allows us to say. The superficial connection is timing and proximity. As 3I Atlas transited through the inner solar system in the months prior to the current fireball anomaly, observations confirmed that it was actively outgassing, releasing material from its surface in response to the increasing solar heating it experienced as it fell toward perihelion. The outgassing signature was consistent with cometary activity, volatile compounds sublimating from the object's surface, carrying with them fine particulate material and potentially larger debris, jetting outward into the surrounding space. This is normal cometary behaviour, observed in solar system comets on every close solar approach. What makes it potentially significant when observed in an interstellar object is the question of where that released material goes. A solar system comet releasing debris near the Sun distributes that material along its orbital path, which, being a closed ellipse or a long period but bound trajectory, keeps the debris within the solar system's gravitational domain. An interstellar object releasing debris near the Sun on a hyperbolic trajectory is doing something geometrically different. The object itself will leave. Some fraction of the material it releases, particularly the finest and lightest particles, may be released at velocities and directions that place them on trajectories different from the parent object's hyperbolic path, potentially including trajectories that, under the right conditions, could intersect Earth's orbit. Whether this actually occurred with 3I Atlas, and whether any such material could have arrived at Earth's atmosphere within the time frame we're discussing, is a question that requires detailed orbital modelling with parameters that have not yet been fully published in the open literature. It is a question that is being asked by researchers. It does not yet have a confirmed answer. Here is where intellectual honesty requires a caveat that is significant enough to be stated plainly, rather than buried in qualifications. The fragment composition evidence from the March 2026 recovery sites, the eucrite-like material identified from Germany, Ohio and Texas, points with considerable specificity toward a solar system origin. Eucrites are igneous rocks whose chemical and isotopic signatures have been traced, through decades of careful laboratory analysis, to a single parent body, the asteroid 4 Vesta, the second largest object in the main asteroid belt. This is not a loose association. The HED chondrite group, howardites, eucrites, and diogenites, has one of the most thoroughly documented source body identifications in meteoritics, confirmed by the Dawn spacecraft's direct orbital observations of Vesta and by the spectroscopic match between HED meteorites and Vesta's surface composition. 4 Vesta is not an interstellar object. It formed in our solar system, in our asteroid belt, approximately 4.5 billion years ago. Its material carries the isotopic fingerprint of our specific solar system's formation environment, a fingerprint that would be different from material originating in another stellar system, which formed in a different molecular cloud with a different isotopic composition. If the eucrite classification for the March 2026 fragments holds up through full laboratory confirmation, it is an argument against the incoming material being directly derived from 3I Atlas. Interstellar objects do not, as far as current planetary science understands, carry asteroid belt material from our solar system. The chemistry does not support a direct causal link between the interstellar visitor and the fireball fragments. This caveat matters, and it needs to be stated clearly in any honest treatment of the 3I Atlas connection. The viral theory that claims 3I Atlas is the source of the incoming material, or worse, that the military is intercepting alien probes associated with it, runs directly into the fragment composition evidence, which points somewhere much more ordinary and much more local. Extraordinary claims require extraordinary evidence, and eucrite fragments from Vesta is not extraordinary evidence for an interstellar origin. It is in fact evidence pointing in precisely the opposite direction. But, and this is the part that the dismissive response misses, the absence of a direct causal link between 3I Atlas and the fireball fragments does not mean that 3I Atlas is irrelevant to the story. It means it is relevant in a different and more subtle way than the viral narrative suggests. What 3I Atlas represents, in the context of the March 2026 anomaly, is not a source. It is a data point in a broader pattern. Consider the full picture that the first quarter of 2026 is assembling. A historically unprecedented fireball rate over Earth, fragment recoveries with unusual compositional characteristics, a debris stream crossing for which no catalogue entry exists. And now, in the same general temporal window, only the third interstellar object ever detected transiting through our solar system, actively outgassing as it passes through the inner system. These phenomena do not share a single cause. The Eucrit composition argues against a unified origin story, but they share something else. They share a context. The context is a near-Earth space environment that is, by any honest measure, more active and more complex right now than its long-term average. More material is entering the atmosphere. That material is larger and denser than the background population. An uncatalogued debris structure appears to be intersecting Earth's orbit. And an interstellar visitor, itself a statistically rare event, with only 3 confirmed detections in the entire history of modern astronomy, is transiting through the neighbourhood simultaneously. None of these phenomena individually requires the others to explain it, but their coincidence in time raises a question that is worth sitting with. Is the current period genuinely anomalous in some broader sense, representing a temporary confluence of multiple independent elevated activity phenomena, or is the apparent coincidence simply the result of better detection capabilities, revealing a baseline that was always this busy and that we simply lack the instruments to fully perceive before? That question does not have a clean answer yet. The honest position is uncertainty, genuine, unresolved uncertainty of the kind that science is supposed to sit with, rather than paper over with premature conclusions in either direction. What can be said is that the simplest explanation for the fireball anomaly remains a solar system debris structure, almost certainly of local origin, with composition pointing toward the Vesta family. 3I Atlas is probably not the cause of what is falling out of the sky over Ohio and Texas. But 3I Atlas is a reminder of something that the fireball data is also reminding us of, from a completely different direction. Space is not empty. The near-Earth environment is not static. The baseline we have been using to define normal was assembled over a period of decades that may not be representative of the full range of what Earth's orbital neighbourhood delivers. We built our sense of normal from a dataset that is, in cosmic terms, extraordinarily short, a few decades of systematic observation against a backdrop of 4.5 billion years of solar system history. 3I Atlas came from somewhere we have never been, travelling through space between the stars for potentially millions of years before entering our solar system for a single brief transit. It carried with it whatever its home system produced and whatever interstellar space deposited on it during that long journey. It outgassed near our Sun, released material into our inner solar system, and will continue on its way without leaving a forwarding address. It did not cause the March 2026 fireballs, but it arrived at the same time they did, and in a story already full of things that should not be happening simultaneously, that is one more coincidence that the data has declined to fully explain away. Part 15. The Vesta debris question. 4. Vesta is a world-sized scar. To understand what that means, you need to hold 2 scales in your mind simultaneously, the scale of the object itself and the scale of what happened to it. Vesta is roughly 550 kilometers across. That makes it not quite a planet, not quite a minor body, something in between, large enough to have differentiated into a layered internal structure with a metallic core, a mantle, and a crust, the way Earth did, but not large enough to have held onto that structure against the violence that the early solar system delivered to everything in its path. It is, in the language of planetary science, a protoplanet, a body that got most of the way through the process of becoming something larger, and then had that process interrupted, permanently and catastrophically. The interruption is written on Vesta's southern hemisphere, in a feature called the Rhea Silvia Impact Basin. Rhea Silvia is not merely a large crater, it is a wound that came close to being fatal. The basin spans approximately 505 kilometers, nearly as wide as Vesta itself, and reaches depths that expose material from Vesta's deep interior, the ancient rocks of the mantle that would otherwise never have seen the surface. The central peak that rises from the basin floor, the rebound structure formed as the crust rebounded upward after the impact's compression wave passed, stands approximately 22 kilometers above the surrounding terrain. Mount Everest, the highest point on Earth's surface, rises approximately 8.8 kilometers above sea level. The central peak of Rhea Silvia is more than twice as tall. It is one of the largest mountains in the solar system, and it exists because something hit Vesta hard enough to nearly break it apart. The Dawn spacecraft, which orbited Vesta from 2011 to 2012 before continuing on to the Dwarf Planet series, gave planetary scientists their first detailed look at this structure from orbit. What Dawn revealed confirmed and extended what meteorite researchers had been inferring from samples on Earth for decades. The collision that created Rhea Silvia, estimated to have occurred roughly 1 billion years ago, did not just scar the surface. It excavated an enormous volume of Vesta's crust and upper mantle, accelerating that material to velocities sufficient to escape Vesta's gravity entirely. The result was a family of fragments, ranging in size from fine dust to bodies hundreds of meters across, scattered throughout the asteroid belt in orbits broadly similar to Vesta's own, but gradually diverging under the influence of gravitational perturbations. These fragments are collectively called the Vestoids, and their family is one of the largest and best characterized collision families in the entire asteroid belt, with thousands of catalogued members and an unknown number of smaller, uncatalogued ones. Over geological time, a fraction of the Vestoid population has found its way to Earth. The mechanism is not direct. It involves a slow, multi-stage process by which gravitational resonances in the asteroid belt gradually modify fragment orbits over millions of years until they become Earth crossers. Mean motion resonances with Jupiter, where a fragment's orbital period falls into a simple ratio with Jupiter's, create zones of gravitational instability that pump up orbital eccentricities over time. Secular resonances, longer period interactions between the precessing orbital planes of fragments and the giant planets, add another layer of gradual modification. Through these mechanisms, material from Vesta has been delivered to Earth-crossing orbits continuously since the Rhea Silvia collision, arriving at Earth's surface as the class of meteorites called HED achondrites, howardites, eucrites, and diogenites, named for their distinct igneous compositions that reflect their origin in the crust and mantle of a differentiated parent body. Approximately 6% of all meteorites that fall on Earth belong to this group. They have been landing here for hundreds of millions of years. Vesta has been shedding pieces of itself into our laps across essentially the entire span of complex life on Earth, which makes the timing question so difficult to answer cleanly. If Vesta has been delivering material to Earth continuously for hundreds of millions of years, why would a surge of eucrit-like material appear specifically in March 2026? The background delivery rate is not zero. Eucrit falls happen. They are rare relative to the more common chondritic meteorites, but they are not unprecedented events. Individual eucrit recoveries appear in the historical record at intervals of years to decades. The American Meteor Society's statistical flag is not that eucrit falls are happening, it is that 2 eucrit-like falls appeared in 9 days at the energy scale of the March 2026 events, and that this clustering is outside the expected probability under a random Poisson process drawing from the background fall rate. The uncomfortable question is what could accelerate that background rate significantly enough to produce the clustering we are observing, and on what timescale such acceleration could operate. The Vestoid family's orbital evolution is normally a slow process. The resonance-driven eccentricity pumping that eventually delivers fragments to Earth-crossing orbits operates on timescales of millions of years for most members of the family. Under ordinary circumstances, the rate of Vestoid material arriving at Earth changes on geological timescales, not human ones. You would not expect to notice a meaningful change in the delivery rate within a single month, or a single decade, or even a single human lifetime. The background is stable at the scale of observation that any living person or institution can directly compare against. But the background rate assumes a relatively stable source population, a Vestoid family evolving gradually under slow resonance dynamics without major new inputs. That assumption can be violated. The specific mechanism that would violate it is a secondary fragmentation event, a collision within the already scattered Vestoid population that produces a fresh burst of new fragments with orbital properties clustered around the pre-impact orbit of the parent fragment. Unlike the original Rhea Silvia collision, which distributed material across a broad range of orbital configurations, a secondary collision within the Vestoid family starts with a parent fragment already in a specific orbit, and produces daughter fragments with orbital elements initially clustered tightly around that parent's trajectory. If the parent fragment happens to be in or near one of the resonance zones that feed into Earth-crossing orbits, the delivery timescale for the freshly produced daughter fragments can be dramatically shorter than the background evolution rate, potentially years to thousands of years rather than millions. The solar system has a long memory, but it also has fresh wounds. Secondary collisions in asteroid families are not rare events on geological timescales. The Vestoid family, with thousands of catalogued members moving on orbits that cross and approach each other over millions of years, has certainly experienced secondary collisions throughout its history. The question is whether one occurred recently enough, in the astronomical sense of recently, which might mean anywhere from decades to hundreds of thousands of years ago, to have injected a fresh population of fragments into orbits that are now delivering material to Earth at an elevated rate. We do not currently have confirmed observational evidence of a recent secondary collision in the Vestoid family. No specific event has been identified in the asteroid survey data. No newly formed fragment cluster has been catalogued with orbital properties that directly predict the March 2026 delivery geometry. What we have is considerably more indirect. Fragment candidates from 3 recovery sites carrying preliminary compositional assessments suggesting Eucrit affinity, a statistical flag from the American Meteor Society on the clustering of those falls, and a broader fireball anomaly whose size distribution and energy scaling are consistent with a fresh injection of material from a disruption event, rather than a draw from the long-established background population. That is a convergence of suggestive evidence, not a chain of confirmed facts. The distinction is important and should not be elided, but suggestive evidence pointing consistently in the same direction is how scientific investigations begin, not how they end. The thread is real. It connects the March 2026 anomaly to a specific physical mechanism, secondary fragmentation within the Vestoid family, that is documented, understood, and entirely consistent with known solar system dynamics. It does not require exotic physics, classified programs, or interstellar intervention. It requires only that something in the asteroid belt, at some point in the recent astronomical past, broke apart in the right place and sent the pieces toward us. That is a quiet kind of unsettling. Not the dramatic, cinematic unsettling of an alien contact story or a government cover-up narrative. The quieter, more persistent unsettling of realizing that the solar system has been conducting its own business for 4.5 billion years, generating collisions and debris and fragmentation cascades on timescales and in locations that our few decades of systematic observation cannot fully characterize. We are watching the downstream effects of an event we did not witness, cannot precisely date, and cannot yet confirm even occurred. We are reading the arrival of the debris and working backward toward the cause. The debris did not come from nowhere. Something made it. We just do not know yet exactly when, or exactly where, or exactly how large the thing that made it was. And in a story that has already produced more questions than answers, that particular unknown sits near the top of the list of things that the next round of laboratory analysis and orbital modelling may finally begin to resolve, or may deepen further. The asteroid belt is not done with us. It has never been done with us. It has simply been quiet enough for long enough that we mistook the quiet for safety. Part 16. The military intercept narrative. Within days of the most prominent March 2026 fireball events, a theory began circulating on social media platforms and fringe news sites that deserves to be addressed directly, because ignoring it would be a kind of epistemic cowardice, and mocking it would miss something genuinely interesting about how humans respond to unexplained phenomena. The theory, stated plainly, goes like this. The fireballs are not meteors. They are debris from alien spacecraft, probes or vehicles associated with the interstellar object 3I Atlas and the United States military, using classified directed energy or kinetic interceptor platforms, has been shooting them down before they can reach the surface intact. The sonic booms are not atmospheric shock waves from hypersonic rock. They are intercept events, the acoustic signature of weapons fire or explosive neutralization at altitude. The recovered fragments are not meteorites. They are cover stories, physical props in a disinformation operation designed to provide a naturalistic explanation for events that are anything but natural. The Eucrit classification is not a mineralogical assessment. It is a layer of scientific-sounding camouflage applied by institutions whose first priority is managing public perception rather than communicating truth. And the geographic concentration of events over the continental United States does not reflect population density or reporting infrastructure. It reflects the deployment zone of the interceptor systems, the simple geometric consequence of where the defense platforms are positioned. This theory reached millions of people within 72 hours of the Ohio event. Not thousands, millions. It moved across platforms with the velocity that only a narrative combining government secrecy, alien contact, and immediate physical danger can achieve, because that combination hits several of the deepest triggers in human threat assessment psychology simultaneously. The videos presenting it accumulated view counts in the tens of millions within a week. Comment sections filled with people reporting that they had heard the booms personally and now understood what they had actually been hearing. The theory did not stay on the fringe. It migrated into mainstream social media feeds, into group chats, into conversations between people who do not normally engage with conspiracy content at all. It is worth asking why before asking whether, because the why turns out to be more illuminating than the whether. The theory is not entirely without internal logic. This is the uncomfortable admission that honest analysis requires. If you begin by assuming the existence of classified directed energy or kinetic interceptor weapons platforms capable of engaging targets in the upper atmosphere, and if you assume a global surveillance architecture capable of detecting incoming objects with sufficient lead time to enable intercept, and if you assume that the interstellar object 3I Atlas was carrying or deploying probes of some kind, then the observable evidence is technically consistent with the narrative. The sonic booms fit intercept acoustics. The geographic concentration fits a deployment zone. The fragment recoveries fit a cover story operation. The official dismissal fits an institution with something to hide. Each piece of the observable record can be reinterpreted within the framework, and once the framework is accepted, the reinterpretations feel mutually reinforcing. This is precisely why technically consistent with and supported by are not the same standard, and why the distinction between them matters enormously. A sufficiently flexible explanatory framework can be made technically consistent with almost any set of observations. The question is not whether you can construct a story that fits the facts. The question is whether the story requires fewer assumptions than the alternatives, whether it makes predictions that can be independently tested, and whether the physical evidence, examined without pre-commitment to the conclusion, points toward it or away from it. On all three of those criteria, the military intercept theory fails, not catastrophically, not in ways that require complex debunking, but straightforwardly and on the most basic evidentiary grounds. Start with the fragments, because they are the most direct physical evidence available and the hardest to argue around. The recovered meteorites from the March 2026 events show fusion crusts, the thin, dark, glassy coating that forms when a rock moving at hypersonic velocity has its outermost surface layer melted by frictional heating during atmospheric entry, then rapidly resolidified as the object decelerates. Fusion crusts are a specific physical structure with a specific formation mechanism. They form on rocks entering atmospheres at the velocities produced by solar system orbital mechanics, typically somewhere between 11 and 72 kilometers per second relative to Earth. They do not form on fragments produced by weapon intercepts, because weapon intercepts do not accelerate material to those velocities. An explosive intercept at altitude produces fragments moving at the velocity of the explosion, plus whatever residual velocity the target had, nothing close to the hypersonic entry velocities that produce the thermal ablation signature recorded in a fusion crust. The interior textures of the recovered fragments tell the same story. Igneous crystalline structures, mineral assemblages, isotopic compositions consistent with formation in a high-temperature, slowly cooling magmatic environment billions of years ago. These are not the characteristics of spacecraft materials or intercept debris. They are the characteristics of rocks that formed inside a differentiated planetary body, spent billions of years in the cold of the asteroid belt, and then entered Earth's atmosphere at orbital velocity. No credible materials scientist who has examined samples from these events has suggested that the composition, texture, or structure is inconsistent with natural meteoric origin. The physical evidence is not ambiguous on this point. It is clear, and it points in one direction only. The sonic boom argument also dissolves under basic acoustic physics. Kinetic intercept systems and directed energy weapons do not produce the specific infrasound signatures that the March 2026 events generated. Bolide atmospheric entries create a characteristic low-frequency pressure wave that propagates over hundreds to thousands of kilometers and is recorded by infrasound monitoring networks, the same networks maintained globally by the Comprehensive Nuclear Test Ban Treaty Organization to detect nuclear detonations. The waveforms from March 2026 events match the established signatures of large bolide entries. They do not match weapons fire. Infrasound analysis is a mature enough field that distinguishing between these sources is not a matter of interpretation. It is a matter of reading the wave characteristics that the physics of each source type uniquely produces, and yet the theory persists and spread and reached millions of people and continues to circulate. Not because those millions of people are gullible, that framing is both condescending and analytically useless. The people who encountered this theory and found it plausible are, by and large, people who notice something that is genuinely true. The official explanation for the March 2026 fireball anomaly does not fit the data. That observation is correct. Seasonal variation and sporadic activity cannot account for a 4.5 sigma deviation. The equinox effect cannot scale to several 100% above the mean. The reporting infrastructure argument cannot explain why only high-end events surged while low-end events remained flat. The official story has a gap in it, a real, measurable, statistically demonstrable gap, and people can tell when a gap exists even if they cannot formally quantify it. Nature abhors a vacuum. So does the human need for meaning, and specifically the human need for an explanation whose scale matches the phenomenon being explained. When something extraordinary happens and the official response is to invoke ordinary mechanisms that obviously cannot account for the magnitude of what occurred, the cognitive vacuum that results gets filled. It gets filled with whatever narrative is available, structured, emotionally coherent, and scaled appropriately to the perceived magnitude of the event. The military intercept theory is all of those things. It is structured, it has clear actors, clear mechanisms, clear motivations. It is emotionally coherent. It combines threat, concealment, and revelation in the pattern that human beings find narratively satisfying. And it is scaled appropriately. It posits a response commensurate with the strangeness of what is being observed. An alien contact scenario handled by classified military assets feels proportionate to 10 unprecedented fireballs in a month in a way that sporadic variation simply does not. This is the genuinely interesting part of the military intercept story, and it is interesting in a way that extends well beyond the specific theory itself. The viral spread of this narrative is a measurement. It is measuring the gap between the official explanation and the public's intuitive assessment of whether that explanation is adequate. When that gap is small, when institutions offer explanations that are clearly proportionate and clearly grounded in the evidence, viral alternative theories do not gain this kind of traction. They exist because they always exist, but they stay on the margins. When the gap is large, when the official explanation is transparently inadequate and institutions respond to pointed questions with language that sounds like deflection, the alternative theories migrate to the center. The military intercept narrative is a symptom. What it is symptomatic of is the same problem that every section of this video has been documenting from a different angle. The official story does not fit the data, and the absence of a credible alternative explanation from the institutions whose job it is to provide, one has left a space that something was always going to fill. The theory is wrong. The fragments are meteorites. The booms are bolides. 3i Atlas did not send probes. The military is not shooting anything down. But the instinct that something real and unexplained is happening, that instinct is not wrong at all. And the explanation that actually fits the data, the one that does not require alien spacecraft or classified weapons, but is still genuinely unsettling in its implications, is the one we've been building toward this entire time. Part 17, the something bigger. Question. Let me address the thing directly, because if you have followed this far, it is sitting in the back of your mind whether you want it to be or not. We have established that a debris stream structure is the most physically consistent explanation for the March 2026 anomaly. We have established that debris streams can be stratified, with smaller leading-edge material preceding larger stream core material. We have established that the analogy of scouts preceding something larger is grounded in documented stream dynamics. So the question is, should we be worried about a large undetected object following the fragments we have already seen? Here is the honest answer, with all the uncertainty that comes with it. The Near-Earth Object Survey programs, primarily the Catalina Sky Survey, Pan-STARRS, and the Atlas Network, are genuinely capable tools. Between them, they have catalogued thousands of near-Earth asteroids, including the vast majority of objects larger than 1 kilometre that could threaten civilization on a global scale. If there is an object in that size range in an Earth-crossing orbit that has had any significant time to be surveyed, there is a good chance we have found it. The SpaceGuard goal of finding 90% of kilometre-scale near-Earth objects has been substantially achieved. But there are gaps. Dark objects, low albedo bodies that reflect very little sunlight, are harder to find than bright ones. Objects that approach from the sunward direction are in a region of sky that ground-based telescopes cannot observe during daylight. Objects that are in the 100-metre to 300-metre range, large enough to cause enormous regional damage but small enough to be statistically numerous, are incompletely catalogued even by current programs. And objects embedded in debris streams, surrounded by fine material that makes them harder to isolate against the background, present specific detection challenges that open sky surveys are not optimized for. The debris stream scenario, applied to the current situation, does not require the existence of a large imminent impactor. The anomaly is fully consistent with Earth traversing a region of elevated debris density containing objects in the fireball to bolide size range, things from 1 kilogram to a few tens of tons, without any larger coherent body following behind. That is actually the most likely scenario. Large coherent bodies in Earth-crossing orbits are found with high efficiency by current surveys. The scenario of a currently undiscovered large impactor on a short-term collision course is constrained by those surveys to be very unlikely. What is not fully constrained is the scenario of a dark sub-kilometre stream-embedded object in an orbit that places it in our current survey gaps. That is a genuine and quantifiable incompleteness in our knowledge, not a certainty of danger, an incompleteness of knowledge. The distinction matters enormously, and the appropriate response to it is continued observation, expanded survey capacity, and honest communication about what we do and do not know. What it is not is panic, but it is also not comfortable. Part 18, the Near-Earth Environment Context. It is worth noting briefly that the March 2026 fireball anomaly is not happening in an otherwise quiet period for near-Earth space. An object designated 2026 FG6 completed a close Earth approach during the same window, adding to a list of tracked near-Earth objects that made notably close passes in the first quarter of the year. The aggregate picture, multiple independent observations of elevated activity in near-Earth space, across different detection methodologies and different size ranges, is consistent with the idea that Earth is currently moving through a region of the solar system with elevated material density. Not unprecedented, not catastrophic, but denser than the baseline that modern civilization has been operating against since the beginning of the space age. The near-Earth environment is dynamic, and the current period appears to be a dynamic one within that already variable system. Part 19, the April window. Looking forward from where we stand at the end of March 2026, two cometary objects occupy positions in their orbits that make them worth noting, if only briefly. Comet C/2026 A1, designated MAPS, and Comet C/2025 R3, designated Pan-stars, are both in orbital configurations that bring them into the inner solar system during the April timeframe. Neither is a collision threat. Neither is predicted to deliver significant additional material to Earth-crossing orbits in a timeframe that connects directly to the current anomaly. But they matter as observational markers. If the debris stream hypothesis is correct, if Earth is traversing a structured region of elevated material density, then the coming weeks should show either continued elevated fireball rates, a peak and decline as Earth exits the denser region, or a second elevation as the geometry shifts. Any of those outcomes would be informative. The April observational window, with these two cometary objects providing additional calibration points for the near-Earth debris environment, may offer the kind of before and after comparison that helps planetary scientists decide whether March 2026 was a single anomalous crossing or the beginning of a more extended period of elevated activity. Watch the numbers in April, they will say something. Part 20. Final synthesis. What changed? Let us come back to the beginning. 10 significant fireball events in a single month, against a long-run average of 2 and a previous record of 6, a 4.5 sigma deviation, 79% sonic boom rate, average witness counts nearly 3 times the previous record. Fragments recovered from 3 separate events showing the same rare mineral composition. No clean radiant. Energy distribution skewed toward larger objects. Geographic concentration without a clean explanation. 3 explanations compete for that data. The first, statistical anomaly. Rare fluctuations happen, and this is one. Nothing has changed in the fundamental environment. We are watching the tail of a distribution that we rarely sample, and it looks strange precisely because it is rare. This explanation is available. It is not compelling, because it requires all of the independent anomalies to fluctuate simultaneously in the same direction by unrelated chance, and the combined probability of that approaches numbers so small they start to lose meaning. The second, a dense debris region. Earth has entered, or is crossing through, a region of near-Earth space with elevated material density, a stream, a distributed field, a gravitationally concentrated remnant of a larger disruption event. This explanation accommodates almost every anomaly in the dataset. The lack of a radiant fits a diffuse stream structure. The size distribution shift fits fragmentation debris. The sonic boom rate fits dense, rocky, stream core material. The fragment composition fits a structured source, possibly vestoid material recently disturbed by a secondary collision. The geographic concentration fits a stream geometry that preferentially exposes one hemisphere to the incoming flux. This is the most parsimonious explanation. It requires the fewest independent assumptions and accommodates the most data points. The third, overlapping phenomena. Multiple independent processes are elevated simultaneously. A stream crossing combined with a recent vestoid disruption, combined with an anomalous seasonal period, together producing a compound anomaly that looks coherent, but is actually the sum of several distinct effects. This explanation is harder to evaluate because it is more complex, but it is not implausible. Real anomalies are often compound. The real world does not always produce single, clean explanations. Here is what I can tell you with confidence at the end of all of this. Something about Earth's interaction with the near-space debris environment in March 2026 is outside the range of normal variation. It is outside the range of known seasonal effects. It is outside the range of what reporting infrastructure improvements can explain. It is producing physical objects, fragments of rare asteroid material, on the surface of the Earth at a rate, and with a composition that statistical coincidence alone cannot easily account for. And it is doing all of this simultaneously, across independent measurement systems, in a convergent pattern that points toward a structural explanation rather than a random one. The debris stream interpretation does not require anything exotic. It does not require classified technology, interstellar intervention, or physics that we do not already understand. It requires something potentially more unsettling in its ordinariness, the recognition that Earth moves through a solar system that is not as empty or as predictable as our civilization-scale planning has generally assumed. We mapped the large threats. We built surveys for the obvious hazards. We characterized the known annual streams and put them in the catalogue. What we have not fully mapped is the uneven, clumpy, dark, diffuse background of material that does not have a name in the catalogue, the stuff that a stream crossing at the wrong moment can deliver without warning. We are not being targeted. No mechanism, natural or otherwise, is directing these events at us. What we may be experiencing is simpler and stranger than targeting. Motion. Earth is moving at 30 kilometers per second through a solar system that is littered with the wreckage of 4.5 billion years of collisions, disruptions, and gravitational chaos. Most of the time, we pass through relatively clear space. Sometimes we do not. The data from March 2026 is consistent with the possibility that we have entered something, a denser region, a structured stream, a zone where the debris is thicker and the fragments are heavier and the sky is busier than the baseline we built our risk models on. We will not know for certain until the April data comes in, until the fragment classifications are confirmed by laboratory analysis, until the radiant scatter is mapped more precisely and compared against known stream structures. Science moves at the speed of verification, not the speed of anomaly. But the anomaly is real. The numbers are real. The fragments sitting in geology labs in Germany and Ohio and Texas are real. Something changed in March 2026. We may not be alone in the dark, but we may not be as safe in it as we thought.